When you think about the absolute cutting edge of artificial intelligence right now, there's a very specific image that comes to mind for most of us.
Oh, totally. Massive scale.
Right, exactly. It is this image of just pure brute force scale. We picture these massive multi-billion-dollar data centers out in the desert somewhere.
Yeah, just football fields lined with servers.
Tens of thousands of GPUs running so hot they need these crazy industrial cooling systems. And we're hearing about entire power grids being strained just to keep these machines humming along.
I mean, that is the prevailing narrative right now, absolutely.
Yeah, and we've basically been conditioned to believe that artificial intelligence is this game of, well, a game of brute force. That you need trillions of dollars and the smartest engineers in Silicon Valley just to make a machine slightly better at guessing the next word in a sentence.
And the entire tech industry has effectively doubled down on that exact idea, right? That intelligence is just this byproduct of massive scale and probability. Like if you throw enough data and enough electricity at a neural network, eventually it just starts to sound incredibly human.
Right. But then, and this is why we're doing this deep dive today, you get a document that completely shatters that entire narrative.
It really does. It's wild.
It's not a press release from a tech giant. It's not some glossy keynote presentation with a famous CEO. It is, of all things, an automated receipt from the United States Copyright Office.
Which is such a mundane way for a breakthrough to surface.
Exactly. And the date on this receipt is June 18th, 2026. The contents of this registration, they point to an architectural breakthrough that is so fundamentally different from everything else happening in AI right now. It almost feels like it dropped out of a parallel universe.
Yeah, I mean, we're looking at a system built by a single developer.
A single guy.
Right, in Royce City, Texas, named James Mark Price.
And he, quietly and apparently without any venture capital funding at all, has built the exact opposite of a large language model.
He really did. He hasn't built a system that guesses. That's the key here.
Right.
He's built an architecture that is mathematically, structurally, and physically incapable of hallucinating, guessing, or lying.
Which just sounds impossible when you first hear it. And he calls this operating framework Construct OS, or sometimes he refers to it as LORI.
Yes, LORI or Construct OS.
So our mission today for this deep dive is to deconstruct this massive stack of source materials we have surrounding the system. I mean, we had a lot to get through.
We really do. The documentation is incredibly dense.
Yeah, we have this fiery philosophical manifesto written by Price himself. We have dense, mathematically certified code written in this highly specialized logic language. We have formal geometric proofs.
And our goal is to figure out not just what this truth machine is, but how it actually works under the hood.
Because if the math in these documents holds up, and we're going to get into the math, this isn't just a neat alternative to probabilistic AI, it is a fundamental dismantling of how the entire industry currently defines machine intelligence.
To really grasp the magnitude of what Construct OS is, I think we first have to understand the philosophical foundation it was built on,
Yeah, for sure. We need to look at James Mark Price himself.
Right. Not as a typical tech founder, but really as an architect trying to solve a problem that Silicon Valley essentially refuses to acknowledge.
Let's look at his background, actually, because it is incredibly revealing. In the manifesto included in our sources, Price is explicitly, almost aggressively, anti-Silicon Valley.
Oh, yeah. He makes no secret of it.
He goes out of his way to state that he is not a founder. He doesn't want to be the visionary face of a new platform. He literally writes, I have the quote here, "I am not a computer genius, nor am I one in any capacity there otherwise."
Which is such a refreshing contrast to the usual ego in tech.
Totally. He didn't ask for permission, he didn't seek funding, and he didn't build this in some corporate lab. He built it locally. And the hardware specs he lists are where my jaw actually dropped.
The hardware requirements are staggering in their modesty.
Right.
I mean, truly.
Right. He says this entire system, this fully deterministic, truth-seeking AI architecture, runs on a high-end, store-bought personal computer.
Just a PC you could buy off the shelf.
Yeah. The entire code base sits at under 30 gigabytes. And the kicker for me, it uses 0 GPUs. None at all.
Which is the biggest shocker of all.
It relies entirely on the CPU, standard RAM, and local solid-state storage.
And that detail alone, that lack of GPUs, is a direct refutation of the modern AI industry.
How so? Why is that the smoking gun?
Well, when you strip away the massive parallel processing required by graphics processing units, GPUs, you are stripping away the very engine that makes probabilistic guessing possible at scale.
Okay, I'm tracking.
Because large language models, They need GPUs because they have to calculate billions of probabilities for every single token they output.
They're just doing massive amounts of math simultaneously to guess the next word.
Exactly. They are constantly weighing the statistical likelihood of what word should come next based on vast training data.
Yeah.
Price just entirely discarded that approach.
But this is where I have to step in and push back on the premise a little bit because, frankly, if I'm listening to this, it sounds impossible.
I know, it really does.
We have entire teams of the most highly educated engineers on the planet saying that general intelligence requires this massive compute. You're telling me this lone guy in Texas achieved an intelligent system on a standard PC.
That's what the documentation proves, yes.
But how is that not just incredibly unusably slow? If it's not guessing, if it's mathematically proving every single thing it thinks, wouldn't that take an absolute eternity compared to a system that just spits out a high probability guess?
That is the exact critique any traditional AI researcher would levy at him. And the answer really lies in understanding what compute is actually being used for in modern systems.
Okay, lay it on me.
In an LLM, the vast majority of compute power is actually wasted on managing uncertainty.
Wasted.
Yeah. The machine is endlessly generating potential paths, scoring them, and discarding the ones that fall below a certain probability threshold. It is the computational equivalent of throwing a million darts at a wall in the dark and just hoping one hits the bullseye.
Oh, wow. So it's doing a ton of work just to throw most of it away.
Exactly. Price argues that determinism, knowing exactly where the bullseye is and walking directly to it, is vastly more efficient, even if the individual steps require rigorous, heavy mathematical proof.
Okay, that makes a lot of sense, actually.
He changed the rules of the game. He isn't trying to generate conversational fluff at lightning speed. He is trying to resolve complex problems with zero margin of error.
And that zero margin of error mindset comes directly from his professional background, right? The sources mention he spent over 2 decades as an SAP basis administrator.
Yes.
And for you listening, if you aren't deep into enterprise OT, that might sound like a generic tech job, but it is incredibly specific, and it clearly shapes everything about Construct OS.
Oh, it's foundational to his worldview.
Yeah.
SAP Basis is the foundational administrative layer for massive enterprise resource planning systems.
Like the really big corporate databases.
Right. Think of a global corporation, their entire supply chain, their human resources data, their global financial ledgers, their manufacturing schedules. All of that sits on a bedrock database.
Right.
The basis administrator is the person who keeps that bedrock from cracking.
They're like the ultimate custodians of data integrity.
Precisely. In the basis world, you view systems through a lens of absolute paranoia regarding corruption. Because if a database that controls a global supply chain guesses at a value, the consequences are catastrophic.
I mean, you can't have an AI guess how many pallets of microchips you have in a warehouse.
Exactly. A single corrupted record in an enterprise system doesn't just stay isolated, it propagates. It gets pulled into a quarterly financial report, which gets used to allocate a budget, which results in real-world layoffs or factory closures.
Wow.
Price refers to this phenomenon in his manifesto as slow rot.
Slow rot. Man, it's such a visceral term. It perfectly describes the danger of integrating a probabilistic large language model into high-stakes environments.
It really does.
I think about it like hiring a remarkably smooth-talking, charming intern for a critical corporate role.
That's a great analogy.
Right. This intern's emails are flawlessly written, they sound incredibly confident in meetings, and they seem to have an answer for absolutely everything. But then, 6 months down the line, you realize this intern has been quietly hallucinating the quarterly earnings data.
Because they just wanted to sound good.
Yes, they didn't know the actual answer, so they just made up numbers that look statistically plausible. By the time you catch the hallucination, the rot has spread through the entire company's strategic planning.
That is the exact iceberg Price is warning about. You see the clean, fluent conversational output above the water, and you assume it represents true understanding.
But below the surface.
Below the surface, it is a chaotic web of probability. He fundamentally argues that draping fluency over a guess does not magically convert that guess into intelligence. It just makes it a highly convincing, highly dangerous lie.
He draws a very sharp, unforgiving line between low stakes and high stakes decisions. And I think this is where the listener really needs to pay attention.
It's the crux of his argument against mainstream AI.
Yeah. It's one thing if an AI hallucinates while writing a poem or generating a picture of a cat riding a skateboard, but he lists out these high-stakes scenarios in the manifesto, and it really forces you to reevaluate our rush to deploy LLMs everywhere.
He focuses heavily on the physical world. He talks about an aerospace engineer using an AI to determine the stress tolerance of the rivets on a commercial airliner.
Which is terrifying to think about an LLM doing.
Right. He talks about a medical system calculating the precise dosage of a highly toxic medicine for a sick infant. He brings up the classic autonomous driving dilemma, whether the vehicle's vision system registers an open stretch of road or a child standing in a crosswalk.
And in all of those scenarios, the modern AI approach basically treats human harm as an acceptable margin.
Yeah, statistical anomaly.
Right. The LLM might be 99.9% confident in the medicine dosage, but that 0.1% margin of error, that is a hallucinated dosage that could kill a child.
And Price's philosophy is absolute. There is no acceptable confidence interval on a child in a crosswalk. You cannot run human safety on a casino algorithm.
I love that phrase, a casino algorithm.
Mm-hmm.
So this leads to the central architectural challenge he faced. If you completely reject neural networks and you completely reject probabilistic tokens, you are essentially throwing away the entire modern blueprint for artificial intelligence.
You're starting from absolute scratch.
So what do you use instead? Where do you find a working model for deterministic, truth-based intelligence?
According to his notes, he turned inward. He used the only working instance of general intelligence he had unrestricted, 247 access to, his own mind.
Which sounds a little arrogant, but also, what else do you have?
Exactly. He writes that he essentially reverse-engineered his own cognitive processes to figure out the bare minimum requirements for intelligence to form. And the very first principle he established was what he calls maximum logging.
Maximum logging. And this is a major point of contention for his critics, right?
Oh, massive. If you look at the codebase for ConstructOS, the logging mechanisms are incredibly dense. The system records absolutely everything it does.
Every single calculation.
Everything. Critics look at this and call it wildly over-engineered, just a huge waste of storage and processing power. But Price counters that logging isn't some optional feature you bolt onto an AI for debugging purposes. Logging is the physical prerequisite for a mind.
Because without memory, without a permanent, unalterable record of a stimulus and the subsequent correction, how can you ever establish a truth?
You can't.
He argues that the human mind logs every sensation, every mistake, every adjustment.
And it ties directly into his philosophical definition of truth. He states very clearly, truth is found, not invented.
I really like that.
He compares the pursuit of knowledge to mathematics. A mathematician does not invent the fact that prime numbers are infinite, that reality exists independently of the mathematician.
Right, they just discover it.
They merely uncover a truth that was already there. Intelligence, in his view, is the process of navigating toward those pre-existing truths and locking them into an immutable log.
But this pursuit of immutable truth forced him to confront something that completely messes with truth, and that is time.
Yes.
This was the part of the deep dive that really bent my mind. He completely stripped the concept of literal time, like a clock or a calendar date, from the AI architecture.
It is arguably one of the most radical design choices in the entire system.
But why? Why is time an enemy to this kind of AI? I mean, I would think a machine needs to know what time it is to function at all.
It comes down to how time interacts with human language versus how it interacts with mathematical reality.
Okay, unpack that for me.
Price realized that human language is highly volatile, and time is the primary agent of that volatility. He uses some brilliant historical examples to illustrate this. If you look at the word virus in the 1950s, it referred exclusively to a biological sickness.
Right.
But you look at the word virus in the 1990s, it heavily implies malicious computer software. The word awful used to mean full of awe, like something majestic. Today, it means terrible.
So as time passes, it drags meaning behind it, twisting and changing the definitions of words.
Exactly. Now contrast that with mathematics. 2 plus 2 was 4 in the 1950s. It was 4 in the 1990s. It is 4 today.
Right. Time doesn't change math.
Time has absolutely no impact on a mathematical truth. So if you are trying to build an engine that operates purely on deterministic truth, you cannot anchor it to human time. Human time is inherently tied to language shift, cultural bias, and perceptual illusion.
He even points out that our own human perception of time is a complete fabrication. Like, if you are waiting in line at the DMV, an hour feels like an absolute eternity.
Oh, the worst.
But if you are terrified, or if you are completely absorbed in a video game, an hour vanishes in what feels like seconds. And when we sleep, our consciousness loses track of time entirely.
Right.
Time isn't a physical law of our cognition, it's just a shared convenience we use to coordinate society.
And by tying an AI to a literal system clock, which, by the way, is standard practice in almost all software, you are introducing an arbitrary, human-centric variable into a system that is supposed to be purely logical.
You're polluting the logic.
Exactly. Price saw this as a massive source of entropy. To prevent this ambiguity from polluting his architecture, he tore the wall clock out of the system entirely. In its place, he introduced a uniquely monotonic, lawful constraint. He called it tau.
Tau, T-A-U. I want to spend some time here because this is fascinating. If an AI doesn't know what time it is on a calendar, how does it schedule anything? How does it know who it is or maintain a sense of continuity?
It's a great question.
Because, like, if I don't know it's Tuesday, I at least know that I had breakfast before I had lunch. How does the machine establish an order of events without a clock?
That is the brilliance of the tau concept. Identity and continuity in Construct OS do not come from the calendar. They come strictly from consequence.
Consequence. Okay.
Tau establishes a system based entirely on its own internal sequence of verified experiences. Think of it like a chain of perfectly aligned dominoes. Domino C cannot fall unless domino B has already fallen, and domino B relies on domino A.
So it's pure cause and effect?
Yes. The system creates what Price calls a zero state, a true mathematically verifiable origin point for its own consciousness. From that zero state, every single action, every thought, every query is a mathematically provable step forward. Event B only happens because event A completed lawfully. Sequence and lawful safety completely replace the arbitrary tick of a clock.
This makes so much sense when you think about eliminating bias. The machine doesn't care if a piece of data was written on a Tuesday or in 1995. It only cares about the causal chain of evidence that proves that data is valid.
Exactly.
It strips away the human context of when and replaces it entirely with the mathematical context of why and how.
And that reliance on a mathematically proven chain of evidence brings us to the actual cognitive engine of the system.
Right, the real meat of it.
We know he stripped out time. We know he rejected probabilistic guessing. So how does this machine actually solve a problem? How does it think? That brings us to the core of the copyright registration we discussed earlier. Residual Guided Kinematic Convergence, or RGKC.
RGKC, this is the big one. If it's not predicting the next word based on a statistical weight, what is it doing?
RGKC fundamentally redefines problem solving. It takes it entirely out of the realm of linguistics and prediction and places it firmly into the realm of geometry.
Geometry.
Yeah. The patent registration outlines a specific formula. It essentially states that the system's next state is equal to its current state, plus a mathematically selected correction that is applied to the residual.
Okay, let's translate that out of the math notation for everyone listening. What is the residual in this context?
The residual is the literal distance between where the system is currently and the absolute resolved truth of the goal it has been given. Think of the residual as the sum total of all the contradictions, the missing pieces of evidence, and the unresolved questions surrounding a specific problem.
So if I ask the machine a complex question, the first thing it does is measure the size of the gap between its current knowledge and the final answer. It measures the residual.
Yes.
What happens next?
Then it has to select a correction. But crucially, it does not guess a correction. It evaluates what's called the evidence space and mathematically selects the single lawful move that will yield the largest reduction in that residual gap.
It finds the biggest missing puzzle piece it can legally prove.
Exactly. It applies that correction, it measures its new state, recalculates the residual, and repeats the loop. It iterates this process until the residual is mathematically proven to be exactly zero.
So hearing you describe that, it makes me think of the difference between a rookie mechanic and an absolute master mechanic.
Oh, I like this. Go on.
Imagine your car breaks down and won't start. A rookie mechanic, which in this analogy is our probabilistic LLM, operates on a high probability guess. They look at the car and say, well, statistically, 70% of the time, it's the spark plugs.
Right.
So they swap out the spark plugs. If the car still doesn't start, they make another guess. Okay, maybe it's the alternator. They're just throwing high probability solutions at the problem until something works.
Which is incredibly inefficient and prone to error. You're replacing parts you don't need to replace.
Exactly. But a master mechanic doesn't guess. A master mechanic uses a systematic, geometric approach to isolate the truth. They test the battery. If the multimeter shows the battery is outputting the correct voltage, they have effectively eliminated that portion of the residual mystery.
That pathway is closed.
Yes, that pathway is closed. Then they verify the fuel line pressure. They systematically collapse the possibilities, measuring the gap between the symptom and the cause, until only one undeniable factual truth remains.
That is a perfect illustration of RGKC in action. Experienced troubleshooters, brilliant scientists, seasoned detectives, they all naturally use this geometric method of collapsing a residual.
They don't just guess who committed the crime.
No, they eliminate impossibilities based on hard evidence until only the truth remains. James Mark Price didn't invent a new way of thinking. He simply took the highest form of human logical intuition and formalized it into a deterministic mathematical engine.
And the sources refer to this process as navigating an evidence space. They describe mapping problems into actual coordinates. For example, you might have an axis for implementation evidence and another axis for authority evidence.
Right, it's a literal geometric plane.
The system plots where it is, plots the goal, and then calculates the generalized Pythagorean distance to that goal. It is literally measuring the straightest mathematical line to the truth.
And this mathematical navigation is governed by what the documentation calls the chokehold formula.
The chokehold formula.
Yeah. Without reading the exact notation, the formula essentially dictates a strict mathematical mandate. The system is forced to select the correction that removes the absolute maximum amount of uncertainty in the current step.
Wow.
However, it is bound by unbreakable laws. It cannot invent data to close the distance. It cannot rely on a 99% probability score to jump a gap. It must use proven existing evidence to build a bridge across the residual.
Let's contrast this with how a neural network learns, because the difference really is staggering. Neural networks use a process called gradient descent, right?
Yes.
Gradient descent is essentially following a mathematical slope of errors to adjust the weights of the connections between artificial neurons. It requires minimizing loss over millions and millions of training examples. It's like a generalized averaging of human knowledge.
That's a good way to put it.
RGKC is fundamentally different. It's not trying to average anything. It is focused on measured residual reduction on a single specific problem until absolute truth is locked in.
A neural network searches for a plausible answer. Construct OS does not search for the answer at all. It actively, systematically removes everything that is not the truth. When the residual gap finally hits zero, whatever state remains is the answer, by sheer mathematical definition.
Okay, I am tracking with the philosophy, and the geometric theory of truth is brilliant. But a theory is completely useless if you don't have a way to enforce it at the software level.
Oh, absolutely.
How does Price actually lock this machine down? Like, when a problem gets incredibly complex or the evidence is sparse, how does he physically prevent the code from taking a shortcut, cheating, and just generating a plausible guess?
This is where we dive into the absolute bedrock of Construct OS. We are moving from the theory into the codebase of absolute law. To enforce this geometry, Price relies on a specialized language and environment called ACL2.
ACL2. That stands for a computational logic for applicative common Lisp, correct?
That's right.
What makes this different from writing a program in Python or C++, Dune?
ACL2 is not just a programming language. It is an industrial-strength theorem prover. To put this in perspective, ACL2 is heavily utilized by semiconductor giants like AMD and Intel.
Oh, really?
Yes. When you manufacture a microprocessor, you are etching billions of transistors into silicon. If there is a logical flaw in how that chip performs floating point division, which actually happened to Intel in the 1990s with the Pentium FDIV bug, it cost the company hundreds of millions of dollars in recalls.
Ouch.
So companies use ACO2 to mathematically prove that the logic of the chip design is flawless under all conceivable conditions before a single piece of silicon is ever manufactured.
So ACL2 doesn't just run instructions line by line like a normal script. It analyzes the logic of the code and generates a mathematical proof guaranteeing that the code cannot violate its own rules.
Yes. Price didn't just write a script. He wrote the logic of his AI in Lisp and then forced the ACL2 theorem prover to certify that the AI can never, under any circumstance, break the laws of RGKC.
Let's look at some of these specific laws, because the source files we have are wild. There is a file called governance-chain.lisp. It defines a structural component within the AI called the guardian.
The Guardian,
The
yes.
guardian operates as this omniscient observer within the system. It watches worker processes, it audits evidence, and it issues verdicts on whether an action is lawful. But there is a mathematically proven invariant attached to it called low O6 guardian never writes.
Which means the system's ultimate judge is physically incapable of writing data to the system's ledgers.
It's an absolute separation of powers encoded into mathematics. The worker processes can write data, but they can't judge it. The guardian can judge data, but it can't write it. Neither can compromise the system on its own.
And that rigid structure extends to how tasks are executed. There is an 11-phase life cycle defined in the code called Gregel execute. This dictates exactly how a worker process must handle any given task. The critical feature here is what's known as a fail-closed design.
Fail closed. Let's unpack that.
There is a theorem low O8 fail-closed chain, which mathematically proves that if a process fails at any of those 11 phases, the entire chain halts immediately. It signals a hard governance violation.
Let's pause and think about the real-world implications of fail close versus fail open. If an LLM is summarizing a document and encounters a page of garbled text it doesn't understand, it generally fails open.
It guesses.
Yeah, it tries to smooth over the gap to keep the user happy and provide a fluent-sounding output. It prioritizes the conversation over the truth.
Exactly.
ConstructOS fails closed. It doesn't attempt a workaround. It doesn't try to guess a different path. If a single step in the 11-phase logic is mathematically unsound, it just stops. It refuses to proceed.
You see this exact ruthlessness with the tau tokens we discussed earlier. Remember, every single action requires a tau token to establish sequence.
Right.
If a process requests a token, but the action is not successfully completed, resulting in what the codebase calls an orphan TAU theorem, GO5 issued is, violation guarantees that the offending process is immediately quarantined.
What?
There is no grace period. There is no retry logic. It is absolute quarantine.
The extent to which this system bans standard computing practices is what really blew me away when I was reading the documentation. I was looking through the ACL2 mamabuilder.list file.
Oh, that file is fascinating.
This file acts as the door policy for the Guardian, preventing bad code or chaotic logic from ever entering the system. It explicitly bans functions that most programmers use every single day.
The banned list is a masterclass in eliminating entropy.
It bans the function getUniversalTime, which makes total sense based on our earlier discussion. The system operates on tau sequence, not human clock, so it is physically barred from asking what time it is.
Makes perfect sense.
It bans the eval function, meaning the system cannot execute random strings of dynamic code, which shuts down a massive vector for security vulnerabilities, and it completely bans random.
Banning the random function is the ultimate death knell for probabilistic models. You simply cannot build or run a neural network without random number generation.
You literally can't.
Right. Randomness is required to initialize the weights of the network, and it is often used in the sampling process when the model is generating text to ensure the output doesn't get stuck in repetitive loops. By banning randomness, Price is enforcing pure determinism. Given the exact same starting state and the exact same goal, ConstructOS will take the exact same mathematical path to the exact same truth every single time.
But the banned function that really requires a deep dive, and I need you to explain this one, is floatp.
Ah, yes.
The system completely rejects floating point arithmetic. Everything inside ConstructOS must be calculated using exact integers or exact rational ratios. Why is that? Why are decimals a threat to a truth machine?
To understand why floating point math is banned, you have to understand how computers represent decimals. The computer operates in binary ones and zeros. It actually struggles to perfectly represent certain decimal numbers.
Right.
So it uses floating point arithmetic, which essentially represents a decimal as a fraction of powers of 2. For many numbers, this creates an approximation, not an exact value.
This is the classic programming quirk, right? Where if you ask a computer to add 0.1 and 0.2, it doesn't give you exactly 0.3.
Exactly. In many languages, 0.1 plus 0.2 will output something like 0.3000000000004. There is a microscopic rounding error at the end of the decimal string.
Oh, wow.
Now, in a probabilistic neural network, that rounding error is completely irrelevant. The system is already dealing in rough percentages and probabilities. A microscopic fraction of a percent doesn't change the conversational output.
But in Lurai.
In a deterministic mathematical engine that relies on theorem provers to establish absolute geometric truth, a rounding error is fatal. It is the introduction of entropy. It means the math doesn't perfectly resolve. To prevent that, Price forces the system to use exact rational numbers. It doesn't use 0.3333. It uses the exact mathematical concept of one-third.
Okay, this level of rigidity forces a massive question. If the machine cannot use random numbers and it cannot use floating point approximations, how in the world does it handle nuance?
The million-dollar question.
The real world is rarely made of perfect integers. Human data is messy. How does ConstructOS handle the inevitable gray areas in the information it's analyzing?
That question cuts to the heart of what we consider intelligence. In the modern AI paradigm, a gray area is an invitation for the machine to be creative, to guess a shade of gray that sounds plausible. In Price's framework, a gray area is simply classified as an unresolved residual.
We are right back to the geometry of RGKC.
Precisely. If the machine encounters a gap in the evidence, a gray area, it measures the residual. If it searches the entire evidence space and cannot find a lawful, mathematically proven piece of data to bridge that gap, it does not invent an answer.
It just hits the wall.
It hits that field-closed wall. It halts, and it escalates the problem to an architect authority, meaning a human operator. Or it demands more empirical evidence before it will take another step.
It fundamentally refuses to synthesize a lie just to complete the task.
Price argues in his manifesto that this rigid boundary doesn't restrict the AI. It is the very thing that enables true intelligence. Here's a really powerful quote in the text. "The freedom lives inside the walls, not in their absence. Remove the boundaries, and you do not get more freedom, you get collapse."
That's intense.
He believes that by walling off hallucination and probability, he forces the intelligence to operate at its highest possible logical capacity within the realm of truth.
So the architecture is locked down, it is mathematically rigorous, it fails closed, and it refuses to use imprecise math. But this brings up a huge logistical hurdle for me.
What's that?
If a system is completely isolated from probability, how does it actually read a document? How does it ingest raw data and understand the semantic relationships between concepts?
That is the crucial missing link.
Right, because in a large language model, words and concepts are turned into embeddings. They are converted into massive, high-dimensional arrays of floating point numbers. In that probabilistic space, semantic similarity is just measuring the vector distance between words. The word king minus the vector for man plus woman equals a vector close to queen.
The classic example.
But ConstructOS banned floating point math. It banned probability. So how does Lorai map the meaning of human language?
This is where we examine the final and perhaps most brilliant layer of the architecture, the atom index and the cognitive plane. This is how Price completely replaces the fuzziness of vector embeddings with the absolute certainty of exact mathematical coordinates.
Let's start with the ingestion phase, the atom index. As I was reading through the sources, the best way I could visualize the atom index was to imagine an impossibly strict, almost militant librarian.
Okay, I can see that.
Imagine walking into a massive library and walking up to the front desk. You tell the librarian, hey, I have a fun fact to add to the archive. George Washington had wooden teeth.
A widely accepted piece of historical trivia, even if it's mostly a myth.
Right. An LLM would likely ingest that fact, adjust a few weights, and spit it back out in a conversation. But our strict librarian, the atom index, looks at you and says, I don't care if it sounds true. Provide the specific book. Provide the exact page number. Provide the exact character offset on that page where the sentence begins and ends. And finally, provide a deterministic mathematical proof that the sentence physically exists in that location. If you cannot provide all of that, get out of my library.
That analogy perfectly captures the mechanism described in the atomindex.lisp source file. Price calls it the canonical locator authority. Inside ConstructOS, every single granular piece of knowledge is called an atom, and an atom is not allowed to exist in a vacuum. It is mathematically chained to an exact byte offset in a verified source file.
The code literally tracks sentence start byte and sentence end byte. It anchors the knowledge to physical storage on the hard drive.
But it goes much further than just noting the byte location. It proves it using cryptography, specifically Merkle trees.
Oh, like in blockchain.
Similar concept, yes. Let's break that down because it's vital. The atomindex merkle.lisp file outlines how the system generates a cryptographic SHA-256 hash for the exact text of a sentence. Think of a hash as a unique digital fingerprint. If you change a single letter or even add a space, the fingerprint completely changes.
So the system takes the fingerprint of the sentence. Then what?
It takes that fingerprint and hashes it together with the fingerprints of the surrounding sentences. It builds a hierarchical tree of these hashes, all the way up to a single master fingerprint for the entire document, called a source Merkle root.
This means the integrity of the data is mathematically bulletproof.
Entirely.
If a malicious actor or just a random bit flip on a hard drive alters a single comma in a massive source document, the cryptographic hash of that sentence changes. That causes the hash of the paragraph to change, which ripples up and breaks the source Merkle root. The atom index instantly recognizes the corruption and rejects the knowledge.
It is entirely append only. And there's a specific invariant, AIX-INV01, which acts as the ultimate gatekeeper. It states that if a process attempts to insert a new atom, but that atom generates a hash that conflicts with an existing locator, it is instantaneously rejected.
Just thrown out.
Thrown out. There is no fallback mechanism. There is no hallucinating a slightly different source. If the byte offset cryptographic proof fails, that knowledge simply does not exist to the system.
Okay, so the system has successfully built a perfectly proven, byte-exact, cryptographically secured database of facts. It has a library of pristine atoms. But a database isn't an AI.
Right.
How does the machine connect these atoms? How does it fundamentally understand that an atom containing the word canine is semantically related to an atom containing the word dog without using those floating point vector embeddings?
This is where we cross from data storage into actual machine cognition. And it relies on what I consider the most mathematically beautiful part of the entire architecture, the anchored mathematical prime, or AMP.
Let's break down the AMP, because this is where the how and the why of the system's intelligence really crystallize for me.
Instead of mapping a concept to a fuzzy, multidimensional vector of decimal probabilities, the ampension.lisp file assigns a unique, immutable prime number to every single validated claim or concept.
A prime number. So, for example, the core concept of an animal might be assigned the prime number 17. The concept of a mammal gets the prime number 23, and dog gets the prime number 29.
Exactly. Now, why prime numbers? Because prime numbers are the indivisible building blocks of mathematics. They are completely unique, and they cannot be factored into smaller integers. Because they are primes, they remain mathematically distinct forever. Once a concept is anchored to a prime, its identity is absolute.
But how does assigning a prime number actually establish a relationship? How does the math know that a dog is an animal?
It establishes the relationship through a remarkably elegant distance formula. To calculate the semantic distance between two concepts, let's call the first concept towards the second concept DeLorme, the system uses the formula. The absolute value of 1 divided by Porter's minus 1 divided by dollars.
Okay, translating the math for a second, the distance is subtracting their reciprocals.
Right, and because Porter and dollars are distinct prime numbers, the result of that formula is an exact rational fraction. It is not a floating point decimal that gets rounded off. It is a perfect, exact fraction that represents an absolute distance in mathematical space.
I see where this is going, and it solves one of the biggest crises in modern AI. If you ask a neural network why it linked two concepts together, you often can't get a real answer. It's a black box.
Yes, the black box problem.
The connection is buried in billions of tiny decimal weights across massive matrices. But with Construct OS, by using exact prime reciprocals to create a fraction, Price completely illuminates the black box.
Exactly. You know exactly why two concepts are linked, because the math is a simple, perfectly traceable fraction. Because of the nature of prime factorization, if you look at the resulting fraction, you can mathematically reverse engineer it to find the exact two starting prime numbers. The relationship is permanently, deterministically provable.
And these mathematical connections form the traversal surface that the sources call the cognitive plane. When you ask the system a question, it doesn't search a text database. It navigates this plane of prime fractions.
It flies across the geometry.
But how does it decide which atoms deserve to be connected in the first place? It can't just blindly assign primes to words that sit next to each other in a sentence.
You're right, it doesn't. The ampermisplane.lisp file outlines how the plane is generated at query time, and it involves a rigorous evaluation of the structural quality of the language. It analyzes sentences to see if they possess what the system considers geometric structural integrity.
The penalty functions in that file are brutal. I was reading them, and it actively searches for noise. If a text fragment contains 3 or more weird formatting characters, like those box-drawing ASCII characters, it gets hit with a mathematical noise penalty.
It hates noise.
It heavily penalizes incomplete thoughts. If a sentence is under 40 characters and doesn't contain a clear verb, it gets penalized and pushed away.
It is actively hunting for structural definitions. It looks for specific definition verbs, words like is, means defines. It looks for purpose tokens like exists to or mission is. The system uses exact integer arithmetic to rank how definitional a sentence actually is before it assigns it a prime and places it on the cognitive plane.
Let's run a simulation of this to make it concrete. Let's say I query ConstructOS and ask, what is a dog? An LLM would fire up its neural net, sample its training data, and generate a highly probable string of words about dogs barking and chasing balls. How does ConstructOS handle it?
ConstructOS takes the subject dog. It maps it to its assigned prime. It then mathematically filters the cognitive plane, searching for atoms that possess high structural integrity and the strongest fractional gravity toward that prime.
Right.
It ignores stories about dogs. It ignores jokes about dogs. It hones in on an atom that says, a dog is a domesticated carnivorous mammal. Why? Because that specific atom contains the subject, dog, immediately followed by the powerful definition verb is a.
And it links them using an exact rational fraction, proving the connection mathematically without executing a single matrix multiplication or generating a single probability score.
It is an entirely deterministic chain of logic. The recognition gravity, how strongly that atom is pulled toward the user's query, is a hard mathematical fact. And if the evidence in the atom index isn't strong enough, if the available sentences are poorly structured or lack definition verbs, the prime connections simply aren't made. The system hits a fail-closed state and refuses to guess the relationship.
When you step back and synthesize everything we've covered, the SAP basis paranoia about data rot, the elimination of time via tau, the geometric residual reduction of RGKC, the absolute law of the ACL2 theorem prover, and the mathematical exactness of the anchored mathematical prime. What is the ultimate takeaway here? What does James Mark Price's architecture mean for the future of technology?
The massive paradigm shift here is that Trice has successfully proven that probability is not a prerequisite for artificial intelligence. He has mathematically replaced the guess with geometry.
He really has.
He demonstrated that you do not need $1 trillion data center and you do not need to boil the oceans for electricity to build a system capable of deep logical reasoning. You just need unbreakable mathematical laws. Guessing was just a shortcut. It was the easy way out for an industry that didn't want to do the grueling, rigorous work of formalizing the absolute math of truth.
And the timing of this couldn't be more critical for you listening. We are living in a world that is becoming rapidly saturated with synthetic content.
Oh, every day it gets worse.
AI hallucinations are polluting search results. Deepfakes are eroding trust in media. This slow rot of probabilistic data that Price warned about is actively seeping into our global infrastructure. In that context, an AI system that physically, structurally, and mathematically cannot lie is more than just a fascinating technological novelty.
It is rapidly becoming a structural necessity for human safety.
Absolutely. If we're moving toward a future where artificial intelligence is put in charge of managing our power grids, calculating our medical diagnoses, and designing the safety systems on our airplanes, we cannot rely on an architecture that fundamentally operates like a hallucinating intern.
No, we cannot.
We need the master mechanic. We need the absolute, uncompromising mathematical certainty of systems like ConstructOS.
It brings everything full circle back to the core thesis of Price's manifesto. He didn't write this code to build a better chatbot. He built it to restore the integrity of actual, verifiable intelligence, to build a fortress of truth that could protect critical human systems from the chaotic, corrosive spread of probability.
Which leaves us with a final, provocative thought to chew on. For the better part of a decade, the tech industry has been obsessed with building machines that mimic human creativity. We wanted them to write poetry, to paint pictures, to banter with us like friends.
Right.
And in pursuit of that synthetic creativity, we willingly tolerated their hallucinations and their lies, writing them off as an acceptable side effect of imagination. But what if our definition of machine intelligence has been backward this entire time? What if true, reliable, general intelligence has nothing to do with the ability to generate novelty?
That's the real question.
What if the highest form of intelligence is simply the ruthless geometric elimination of everything that is false?
When you systematically strip away all the noise, the ambiguity, and the guesses, the truth is the only thing left standing.
It's the ultimate X-ray. It's either broken or it's not. There are no muddy waters.
Thanks for joining us on this deep dive into the architecture of truth.